Hey there, this is Kung Fu Physics, where we're currently working our way through practice physics GRE problems. I have another mechanics problem tonight. It's number 55 off of the 2001 exam. So get that out if you've got it at home to follow along. Number 55. Now let's go right into it. I usually just scan the answers. With these answers, it's obvious that this is kind of looking like an elimination problem, because of the texty looking answers. Without having read the problem, actually reading them doesn't help me much. So I just sort of scan them, realizing that it's kind of an elimination-y type of problem. And I will have to read those with much more detail after I finish the text of the problem. So I'm going to take a little quick glance at that diagram there, and then I'll read the text of the problem here. Number 55. A particle of mass m is moving along the x-axis with speed v when it collides with a particle of mass 2m, initially at rest. After the collision, the first particle has come to rest, and the second particle has split into two equal mass pieces that move at equal angles, theta greater than 0, with the x-axis as shown in the figure above. Which of the following statements correctly describes the speeds of the two pieces? Okay, so this is actually a pretty easy problem. You can move to the answers there pretty quick, and I think you could do this quick. But I'm going to make a drawing here, just to be a little more thorough in the case of this video here. So, not drawing to scale here, but here we go. Okay, so this is the initial situation where this guy is coming in with velocity. I didn't leave enough room there for that velocity. But this mass m is coming in with this velocity. So all of the initial momentum, when I see this, I think of momentum is tied up in just mv. That's the amount of momentum here in this direction. In the x direction, I guess, the positive x direction, or going to the right as you look at the piece of paper. Here, you have to have that same amount of momentum. And so what's happened is this guy, as described by the problem, is sitting at rest, and the other two are moving off at some angle, and that's angle theta. They tell us that it is the same angle, theta. Now, one of the only really important things that pops into my head, I think this is the most important thing to solving the problem, is that when I look at the momentum, it has to be equally distributed between these two masses, for starters, because those angles are the same. That would not be the case if the angles were not the same, but as it turns out, they are the same. And so the momentum is all tied up in the linear momentum of these guys. And what you can do is draw the components of their velocity vectors. Of course, velocity is a vector. It adds like a vector, and so you have components here. And so these are not force, but these are velocity components. Okay? And so we could call this v sub x, v sub x, v sub y. I'm taking a very long time to explain this, but honestly, if you had gotten this far, hopefully you would be looking at the answers by now. Because you would realize that v sub x, in this case, has to be, v sub x has to equal 1/2 of v in here. Because the momentum in my final situation is going to be this mass times v sub x plus, there's two of them. That's the momentum in the linear, in the x direction, linear momentum. Now, the only way you may get confused is if you look at the momentum here. It's like this momentum kind of came out of thin air. But there is no net momentum, just like here. There's no net momentum in the y direction here, nor here, because these two perfectly cancel out. So don't be worried about that, I guess. Anyways, so we know that that's equal to m times v, and we see that v sub x is like 1/2 the original velocity. So these components are 1/2 of what the original velocity of this first particle coming in are. Okay, so with that, we should be able to look at our answers easily and get somewhere. So let's look at these answers here. Answer A, each piece moves with speed v. Now, that's a trick answer. I would move right past that if I was actually doing the physics GRE. I know that can't be right. It could be right if the angles were explicitly said to be 0. And you see right there in the text of the problem it says theta greater than 0. That would be the only case in which answer A is right. So they're trying to trick you with that answer. B, one of the pieces moves with speed v and the other moves with speed less than v. That can't be. The angles are the same. Just conceptually, we know that the speeds of the particles have to be the same. C, each piece moves with speed v over 2. This is also a trick answer. In the little analysis I did, I was showed that the x component of the pieces is v over 2, but certainly not the entire velocity, not the speed, because we have to add in the y component. So you can calculate this. I did it earlier when I was prepping this problem. You can figure out what this velocity is in terms of the initial velocity if you want to, but it's not necessary. It's certainly greater than its x component though, right? Okay, one of the pieces moves with speed v over 2, the other moves with speed greater than v over 2. Again, we have they're describing an asymmetrical situation. That can't be right. And then answer E, each piece moves with speed greater than v over 2. Finally, that's looking best to me. Each piece moves with speed greater than v over 2 because I know that the x component is v over 2. Therefore, I know that they must have a y component. So v, you just add those vectorially, and v is going to be greater than v over 2. So I talked a lot. I apologize for that one. Maybe I made a bigger deal out of that problem than I needed to make. It is a very simple conceptual problem regarding momentum, and we're done. Hopefully, if that one was tripping you up, hopefully that little analysis gave you some insights into it. So that's all for tonight. As always, thanks for watching. Best of luck.